All right, so like I said, today we're going to be going over the calculations that we'll be doing for our lab next week. And it's all stuff that we've learned before. So the first part of the lab calculation will be writing procedures. So you're going to have to make a solution inside of your lab next week. And so let's go over how to do the calculations for that. So if you are supposed to make a 200 mil of a 0.5 molarity NaCl solution, these are the procedures you're going to follow. And again, the procedures are always the same thing. You just need to kind of fill in the blanks with the numbers and the chemicals. All right, so let's do our calculation first. So first thing that we want to do, step one, if you guys remember, is we want to convert 200 milliliters into liters. And that's pretty simple to do. All we have to do is divide by 1,000 and to get 0.2. Yeah. Just the procedures. That's going to be your answer. Yeah, the questions are all going to be up on Canvas, or sorry, the questions are all on your lecture notes on Canvas, so you're good. And I have the recording, so you should be fine. Okay, so step one, milliliters to liters. All right, step two is we're going to use the molarity equation. So capital M equals moles divided by liters. And we're going to get the numbers that we have in this problem and plug them into this equation right here. So if you take a look at the problem, capital M molarity is going to be 0.5 molarity. So we're going to do 0.5 molarity equals, we want to find moles, and for our liters, we want a 0.2 liter solution, so 0.2. All right, so the calculation here is pretty simple. We just need to multiply the molarity and the liters. So if you pull out your calculator, you're going to do 0.5 times 0.2, and that'll give you 0.1. So our answer for step two is going to be 0.1 moles, and the chemical is NaCl. All right, and then for step three, what we want to do is we want to set up a fraction, and we want to convert NaCl from moles to grams. So I'll pause right there and give you guys some time to catch up and also try solving that out. Okay, so take about a minute or so. Use your periodic table, find molar mass, and convert moles to grams. All right, guys, so you should have got 58.44 for the molar mass of NaCl. Pretty simple. You just find Na and Cl on the periodic table, add them up. You put them on top of the fraction, 58.44, and then you just multiply 0.1 times 58.44, and that's going to give you your grams of NaCl, which is what we put in the blank on step two. Okay. All right, and then to finish up the procedures, first blank, obtain a 200 milliliter volumetric flask. It's whatever size of solution you want to make. And then you're going to weigh out the chemical on a scale. You're going to add the NaCl to a volumetric flask using a funnel. And then you're going to add water till it reaches the line. And then you're going to stir until it's homogeneous. Okay. So just make sure that you guys are comfortable writing these procedures and doing the calculations. Because when we do our lab next week, I'm not going to tell you the procedures on how to make your solution. You're going to have to do this process right here and follow the instructions that you write to actually make the solution. But again, it's the same thing that we did last week for writing procedures, so it shouldn't be too bad. And we'll have this week to practice for it, so if you need any help or have questions, please let me know. Yeah. You're going to be what? All right, so you're going to make your solution first using the procedures that you write. And then after that, you're going to take that solution. So this is where we can visualize it. We're going to make our solution in the flask, right? You're going to make it, and then you're going to take the chemical out, and then you're going to mix it with a different chemical, and then you're going to run your reaction. And that part is where we do the solution stoichiometry. So we're going to scroll down. And for this one, we're going to work on this together. Yeah, we'll do this part later. All right, but for part B, we're going to be doing solution stoichiometry, and the first step is to balance your equation. So let me give you guys a couple minutes, see if you guys can balance the equation, and if you feel comfortable doing all the steps, you guys can just kind of ignore me and just solve the whole problem out, check your answer at the end. But for everyone else, let's balance first, and then I'll go over it, and then we'll go through the rest of the steps together. All right, so for the balancing, first thing you're going to do is you're going to count the elements, and you should have got these numbers right here, so you could check your answers with the work on my table. But you should first notice you need more Na on the left side, so you add NaCl. That's going to require you to fix up the Cl and the H on the right side, so you just need to add HCl to finish it up. So you should get 2, 1, 1, 2. Okay. Any questions on the balancing? Again, I promised you guys the balancing would not be too difficult for this unit, just because I'm going to assume that you guys know how to do it. So something like that will be pretty typical for you guys. Okay. All right, let's move on to step 2 now. So once you guys balance the equation, we're going to have to identify the starting and the ending chemical. So on your paper, I want you guys to just write down what you think the starting chemical is. Again, this is the one that has numbers associated with it. And I also want you guys to write down what you think the ending chemical is, what you're trying to find in the problem. So take about 30 seconds, just write it down, see if you can identify the starting chemical, the one with numbers associated with it, or the ending chemical, the one that you're looking for. Alrighty guys, so let's take a look at the problem. In the problem, it says that you are taking 50 milliliters of a 0.5 molarity NaCl solution. So the chemical that has numbers associated with it is NaCl. So you are starting with NaCl. And then the question tells you, you run the reaction, you have excess H2SO4. So this is excess, which means we can cross it out. We don't need to worry about it because it's excess. And then saying calculate how many grams of HCl you will produce. So you're looking for HCl in this problem. Okay. Any questions on the starting and ending? Again, the starting is the one that has a lot of numbers associated with it. So the 50 mils, 0.5 molarity, that all has to do with NaCl. That's why NaCl is your starting. And then the question is asking how many grams of HCl. So you're looking for HCl. All right, let's move on to step 3. Step 3 is where we use the molarity formula again for NaCl. And so I'll pause right there, and I'll give you guys a minute or two, see if you guys can plug in the numbers into the molarity formula to find moles of NaCl. It's the same calculation as earlier, but it's just going to be with some different numbers. So try that out. Alrighty guys, so for step 3, you guys should have plugged in 0.5 molarity for NaCl. You get that from the problem, 0.5 molarity. For the liters, it's 0.05 liters because you take the 50 milliliters and then you divide it by 1,000 to get the 0.05 liters. Any questions on where we got those two numbers? Hopefully not too bad. Okay, you multiply them together and that's how you get 0.025 moles of NaCl. That's step 3. Alright, step 4, the last one, the stoichiometry component. We're going to take our answer from step 3, so 0.025 moles of NaCl, and we're going to set up our two fractions. So if you haven't gotten to this step already, let's write down our two fractions. The bottom of the first fraction will be moles of our starting chemical. The top will be moles of our ending chemical, and the second fraction will be moles underneath, and then grams of our ending chemical on the top. So those are the two fractions. The two fractions for step 4 are always going to be the same. It'll be moles, and then grams and moles. Alright, so I'm going to give you guys a couple minutes to finish this part up as well. If you guys remember the second fraction, you're going to get the numbers from your balanced equation. So you're going to look at your balanced equation to plug it in. And then for the second fraction, you're going to get your numbers from the molar mass. And once you've plugged in your numbers, let's see if you can solve it out and get the final answer for this problem. And that's pretty much the calculations for your lab. It's just writing procedures and then this solution stoichiometry. You only have one problem. So the hardest part of the lab is actually doing the chemistry part when you're making it, but the calculation's pretty simple. Alright guys, so let's finish up this problem, and then we got one last component for the lab stuff. Okay, so for the first fraction, you're going to look for the number in front of HCl in the balanced equation, which is 2. So 2 on the top. NaCl also has a 2, so 2 on the bottom. For the second fraction, it's always 1 at the bottom because it's molar mass, 1 mole. And HCl on the periodic table, you should have gotten 36.45. Alright, so let's plug in our numbers. So 0.025 times 2 divided by 2 times 36.45, and that'll give you 0.91, yes. Oh, close enough. Either way, you'll be good. But 36, yes. Close enough. $36.45 versus 46 cents. I'll do it your way, though, because that is technically more correct. My fault. Okay, and you'll get 0.911. Really doesn't change your answer at all. 0.9, I'll just do 91 grams of HCl. All right, guys, so that is solution stoichiometry. Yes. That's correct, yeah. All right, guys, so before we close up, let's go over one thing from the previous unit that we'll need for the lab. So if you guys remember, the answer for your solution stoich problem, we call this the theoretical yield. So let's jot that down on our notes, because part of the lab next week is going to be seeing how good of a reaction can you run. Because based on how good your techniques are, how good you are at making the chemical reaction run well, it's going to determine how much of the chemical you can make. Now, the number that you get from your calculations will always be called your theoretical yield. And then the amount of the chemical you make in your lab will be called the actual yield. Okay, so in this problem, we're not actually running the equation, obviously, but let's say you ran this in your lab and then you got 0.3 grams of HCl. This is going to be called your actual yield. And again, this is how much you make in the lab. So when you guys do your lab, you make your chemical and you finish it off and you weigh it at the very end. The amount you have at the end is called the actual yield. All right, so that's your actual yield. And again, the theoretical yield is how much you made based on your calculation. So we wrote down 0.91 grams. And then lastly, to calculate the percent yield, this is the formula. The percent yield is the actual yield divided by the theoretical yield times 100%. So what you would do is you take your actual yield, what you guys got in the lab, so 0.3 grams divided by your theoretical, the number you got from your stoich, 0.91 grams, and then you multiply that by 100%. Okay, and that's how you get your percent yield, and that's kind of like a grade, right? A percentage of how much you could have made versus how much you actually made. Okay, and so you'll be calculating that in your lab as well next week. Okay, so here we would have something around 32.97%. Something around there is good.